Okay, so hello, my name is Farrell, and this is waves and their application, which is for my physics one project. So first, I want to go through an introduction of myself, and my name is Farrell, and I'm going to be the physicist for today, and I'll be covering an explanation about waves and how we apply their interactions, as well as how those interactions apply in real life for our technologies and stuff. I'm from Physics 111. Okay. So now we're going to go through some simple definitions. I'm going to first go through the definition of the reflection of waves, and second, go through the definition of wave interference. The first one is reflection of waves. Reflection of waves is when a wave or multiple waves hit a barrier and bounce off, basically, in the same angle as the incident ray, unless the surface is rough, in which case the waves are reflected off directly based on the shape of the surface. Okay. Next, we have wave interference. Wave interference can be either constructive or destructive wave interference. Constructive interference is when two waves form another one. However, destructive interference is when two waves cancel each other out. So think about it as for constructive interference is when two waves form a different one, and destructive interference is when two waves cancel each other out. Next, we have some simple theory diagrams here. So first reflection, there is basically it's the incident ray here coming in, and the reflected ray is the same. And that's because this barrier is smooth, therefore that is the case. And here, as you can see, interference is constructive interference here. It's two small waves or different waves, and they form this bigger wave. As you can see, this wave has more amplitude, a higher amplitude as the original waves. Okay, I'm going to move on now. The first demonstration that I can show. This is a mirror selfie. A mirror selfie, for the uninitiated, is a form of selfie that is taken when the camera takes a picture of the light waves that are being reflected by this mirror. Therefore, we have this mirrored image. And so the light waves are reflected at the same angle as the incident ray of light because the mirror is a flat surface that is also smooth. See, mirror's surface is smooth, causing that to be the case. And the last one point here is it is observable that the light is simply reflected at the same angle. Therefore, we have a mirror image. Next, we have the second demonstration using ANC headphones. And this is, as you can see, I've demonstrated here with some drawings. So headphones pick up noise around the room as they form sound waves. You can observe that using the blue line, perhaps, or the pink one. And the blue line here represents the counter noise sound waves that create destructive interference. Noise waves are then neutralized, so the wearer only hears the noise they want to hear, thus the ones being emitted, like music or whatever, from the earphones. And this is just something we can help, we experience every day, so it may help us sort of understand wave interference better. So here's applications of wave interference in real life. Wave reflection in real life. Uh, there's an interference one after this. The first one is sonar tech, which is sonar relies on waves reflecting off of the surface of the bottom of the ocean. The incident ray comes down, and the reflected one comes right back up. And sonar tech can map things based on how waves reflect. If it's smooth, it'll come back at the same angle, and a smooth surface will come up. And if it's rough, it can help us map just the shape of that wave based on the reflection, based on the calculations too. And the wave's reflection can be timed, as we know the speed of the wave, and we can measure the distance using the time and the speed. I think that's a pretty interesting thing about sonar, is that we can, measure a lot of things, locate things, map things in the ocean and in other places as well. In the air, we use radar, which is also the same. Here we have ANC headphones. I touched on it earlier, but basically ANC headphones is a great real-life application of disruptive wave interference. So you can see the mic picks up the noise wave, then the headphones itself can make a counter noise wave that's of the same frequency to neutralize the noise. Thus, the noise wave is canceled, as to why it's called active noise canceling headphones. And yeah, that's why the user can very comfortably use these headphones without hearing anything because the waves uh, are being countered by an equal frequency wave made by the headphone. So I want to go through a simple recap now. So we have reflection of waves and wave interference. Reflection of wave is when a wave bounces off of barriers and surfaces, and wave interference is when a wave interferes with each other either constructively or destructively. And that's it. Thank you very much for your attention and time.